So, by definition, we say something has energy if it can do work, right? If it can do work, we say it has energy. When that energy is because the object is moving, it is said to be kinetic energy. So first part is going to be if an object can do work. If object can do work, we say the object has energy. It has energy. And if that energy is coming because it is moving, if that energy is coming because it is moving, we call that type of energy kinetic, right? We call that energy kinetic. Suppose an object of mass m, we're going to derive the formula for kinetic energy. Let's just say there's an object of mass m, mass equal to m. Let's say it's gradually brought to rest from an initial velocity equal to u. So final velocity is going to be equal to v, which is equal to 0, because we said it's going to be brought to rest. So final velocity is going to be 0, and it's brought to rest by a force equal to F acting through a distance equal to s. So it has acted on a distance of s, and then finally this thing comes to rest, final velocity equal to 0. The kinetic energy originally possessed by the object is equal to the work done, right? Kinetic energy will be equal to the work done against F, right? So the kinetic energy is equal to the work done, which is force times distance, because this is equal to work done, right? We know that work done is equal to force times distance, and this force worked through a distance of s. So our kinetic energy, if an object can do work, it has energy. That kinetic energy is equal to the work done, which is force times distance. But we know that our F is equal to ma. That's one thing we know. So our kinetic energy is just going to be equal to mas, right? From one of our equations of motion, we know that v squared is equal to u squared plus 2as. That's one thing we know, right? So 0 squared, because that's our final velocity, is equal to u squared minus 2as. Therefore, doing a bit of algebra, as is equal to u squared over 2. So our ke, which was given by mas, but we found what as is. So our kinetic energy is just going to be equal to, in a nicer way, half mu squared. That is the kinetic energy that this object had before it started doing the work. When it did the work, that is the kinetic energy that was converted to the work that was done, the work that was done to stop this object. So kinetic energy is half mu squared. We usually see it as half mv squared. The v doesn't mean the final velocity, it just means the speed the object has, right? So that is that. And it's easy. If the object, and we just measure this in scientific notation, this is going to be in kgs, this is going to be in meters per second. So if, let's say, this thing is moving at 36 kilometers per hour, you convert that to 10 meters per second, and let's say it's a mass of 1000 kgs. When you do the calculation, you see that the kinetic energy is just going to be equal to 50,000 joules. Yes, it's measured in joules because we said it is equal to the work done. Work is measured in joules. So that is just kinetic energy. In the next video, we are going to do potential energy.